Hi, my name is James Lewis. I'm the product planner for Agilent's high-performance oscilloscopes. Today we're really excited to introduce the 90000A series of Infiniiums. This new high-performance scope takes our superior signal integrity and extends it with deep application analysis, along with better insight through our new debug capabilities. The 90000A series of Infiniiums feature models starting at 2.5 GHz going all the way up to 13 GHz. Any of the lower bandwidth units can be upgraded to higher bandwidth at any time. Depending on the model, the sample rate will be up to 40 gigasamples on all 4 channels simultaneously, giving you full bandwidth on all 4 channels. The base memory with each unit comes at 10 million samples or 20 million samples, with options to upgrade all the way up to 1 billion samples or 1 gigapoints. The new trigger system in the Infiniium is capable of triggering on glitches down to 250 picoseconds. Alright, now that we know a little bit about the 90000A, let me walk you through some of the new capabilities, such as our low noise front end, our new trigger combinations, as well as our measurement speed even when using deep memory. So let's take a look. To get started, let's take a look at what the new front panel looks like on the new scope. As with our other Infiniiums, each of the channels have their own control knobs and they're color-coded based on the waveform. What's new with these knobs is that they have a vernier function. So for example, if I press the knob and turn it, I move in very small increments on my signal instead of the old style of 1, 2, 5 steps. This vernier function also happens on the time base, so there's a coarse and then there's a fine. Also new is a zoom functionality. So when I press zoom, I have my full waveform as well as the zoomed in waveform. Run and stop now have their own controls so that it's easier to do single shots with the oscilloscope. So let's start by taking a look at the noise performance of the 90000A. So I have one channel on the screen, and I'm going to use the knobs to change my vertical sensitivity to 5 millivolts per division. And then I'm going to turn on a voltage measurement. And we can see that even at 12 gigahertz of bandwidth, our noise floor is around 300 microvolts. So next, let's add a signal and look at what deep memory does. I'm going to do default setup, auto scale. Here I have a signal that's a 5 gigabit signal, which is 200 picoseconds for the unit interval. And I'm going to go over here to set up acquisition and dial in a memory depth. So right now I'm at 1 kilopoints. I'm going to move up to 1 megapoints, and we can see that the update rate doesn't change very much. So I'm going to continue increasing this to 200 megapoints. And I can see that the update rate still hasn't changed very much. I'm going to go ahead and take that all the way up to 1 gigapoints. So we're taking 1 billion samples on this signal, and we're updating several times per second. Just to illustrate how much memory depth is actually being used, I'm going to stop the scope, and I'm going to zoom out to 2.5 milliseconds per division. Since the screen is 10 divisions long, this means I'm capturing 25 milliseconds worth of data, which is equivalent to 40 gigasamples and 1 billion points. So here we can see 2.5 milliseconds, 10 divisions. There's 25 milliseconds of data here. So now let's take a look at what our new trigger capabilities are. So I'm going to start by going into the trigger menu. And the first thing I'll point out is that there are multiple trigger modes now that are new to the Infiniium, such as edge transition, edge then edge, runt, setup and hold, and window. So I'm going to start by looking at glitch. I'm going to ask the scope to trigger on a glitch that is less than 250 picoseconds. And we can see that we have a single pulse in the middle of our screen. And so if I put a pulse width measurement onto the waveform, I can see that we're measuring 190 picosecond pulse. New to the Infiniium 90000 is Infiniscan, which is our software filter capability, is integrated into the trigger system. And so if I go back to the trigger menu, I can turn on Infiniscan and use our unique zone qualify feature to filter out whenever there are pulses to the left of the triggered pulse. So I'm going to draw a box and say that zone 1 must not intersect. And now we're no longer triggering whenever there's a pulse over to the left. Now I'd like to demonstrate what integrated debug tools means. And so what we're looking at in this case is a 5 gigabit signal using a real-time eye, which requires clock recovery. Since the measurement is integrated into the main application, all of our scope tools such as markers and measurements are available to us. If there's something in the eye diagram that looks interesting, we can actually turn the eye diagram off and go directly to the waveform. So now when I zoom out, I can see that my waveform data is available. Now let's have a look at the Infiniium's measurement throughput performance. In this example, we're going to show how we can make over 150,000 measurements per second. So in this case, I have 5 measurements turned on: period, fall time, rise time, and then the negative and positive pulse widths of my signal. I'm going to start running the scope. And what we'll see is that the scope updates once every about 1.5 seconds, and each time it does, it adds approximately 30,000 measurements to each individual measurement. This means that every second the scope is making over 150,000 measurements. So obviously, a few minutes isn't enough time to talk about all the great new features in the 90,000A scope. In addition to these new features, the 90,000A has a much larger, crisper display powered by the Mega Zoom technology. This new platform brings a level of performance that wasn't available in the industry until now. Please visit our website for more information. Thank you.